All right, welcome. We're going to go ahead and get started. So you are here because you either have or you are considering either building or extending your workload across multiple AWS regions. Now, whether that is to improve performance for a globally distributed user base or increase availability for some of your most critical workloads, or to come into compliance with data residency laws and regulations, you've likely realized that this can get quite complex. So whether you're just getting started or if you're deep into the weeds trying to figure out the best path forward, there are a lot of decisions to make. Throughout the session, we're going to look through some real-world scenarios and extract best practices that you can take home today to help you in your multi-region journey. So welcome to this 300-level session on best practices for creating multi-region architectures on AWS. My name is Joe Chapman. I'm a principal solutions architect, and I'm joined by my colleague Niraj Kumar, who is a principal technologist. Over the past few years, Niraj and I have been in a lot of customer conversations, helping customers to evolve and build their workloads across multiple AWS regions. So we built this session based on these real-world learnings that we extracted from the field, helping customers just like you. Now, as we briefly look at the agenda here, overall, our goal is to provide you with a more clear picture on how you can build and evolve your workload across multiple AWS regions by utilizing known AWS best practices. We're going to dive into two fictitious customer scenarios, which were built based on real-world use cases. And then as we walk through these customer journeys, we're going to extract the best practices from each of those. We're also going to look into the trade-offs, the considerations, the pros and cons of the path that they took, because there really is no one-size-fits-all solution when it comes to a multi-region architecture. So you can understand the differences and the trade-offs and adapt them to your specific workload. Now, if you're still in the decision phases of whether or not you need to deploy a multi-region application or multi-region workload, it's important to remember how AWS regions are built. And AWS regions are built to be resilient by design. Customers benefit from 3 or more availability zones in every single public AWS region. And these availability zones consist of 1 or more discrete data centers within the availability zone. Each separate availability zone is then separated by a meaningful distance from the other availability zones. And they're separated by the meaningful distance, taking into account things such as separate power substations, separate floodplains. So if there was a disaster where there was a flood in one data center, it wouldn't affect other data centers within that different AZ within that region. Each of these AZs are also connected through high throughput, low latency links, which allows you to build resilient applications with very low latency between the different availability zones. You can even build synchronous applications that are designed within that regional boundary. The core thing I want to just emphasize here is that AWS regions are built to be resilient. Some of you that may have been building on top of AWS for some time, this might be common knowledge for you. But as you're doing design reviews, as you're doing well-architected framework reviews with others within your organization, take that special look and that special lens on the workload and really determine if the workload is taking advantage of the resilient design and resilient nature of AWS regions. Because if you're not well-architected in a single region, going to a multi-region might not help. It could actually make things worse. For example, by extending problems across multiple regions, extending operations, and extending dependencies across multiple AWS regions. Now, many of you do have strong reasons to go to a multi-region architecture. And as you get started on this journey, the first thing I encourage you to do is really kind of take a step back and really understand the current architecture. What is made up of the current architecture? What are the requirements of it? And what are these new requirements that the architecture and the workload needs to be able to accommodate? For example, if you need to improve performance for a growing global audience, how is performance measured? And what are the current performance metrics? And what are the future performance metrics that need to be understood and accomplished? Or if your requirements say that you need to increase availability for the workload, what are the current availability requirements and what is the current workload achieving? How is that being measured? And how is that going to be measured and what does it need to achieve in the future? Or if you have requirements for data residency laws and regulations that you need to come into compliance with, what exactly are those requirements that are set within those laws and regulations? For example, where can data be stored? Or where can data be transferred? Who can have access to the data? And most importantly, what are the requirements that need to be put in place, such as guardrails, to ensure that data doesn't transfer, data doesn't move where it's not supposed to? So as you understand these requirements and get in line with both business and technology stakeholders and understand the requirements and then work backwards from those requirements to figure out what the best solution is for you. Ask, can a single region meet those requirements, or do these requirements dictate that we need to extend beyond into a multi-region workload? And having both business and technology stakeholders in the room in agreement here is going to help to level set across the organization on the cost, the complexity, and the trade-offs. And it's really going to set the foundation for your journey into a multi-region workload. So understanding the requirements is the first fundamental in creating a multi-region workload. Next, I'm going to hand it over to Niraj, and we're going to walk through our first customer scenario.
Thank you, Joe. And hello, everyone. Welcome to reInvent, and welcome to this session. Thank you for coming this late in the day. So just to build on what Joe mentioned earlier, we have a couple of stories, a couple of scenarios to share with you. And the characterization of these stories or the customers is fictitious, but really the lessons that we are bringing to you and the best practices that we are bringing to you through this session are very much real, not just to, but working across a multitude of customers in different industry verticals. So we have really tried to distill those lessons that we've run from the field into these couple of stories. So the first story we're going to talk about is about a Fintech retail bank. It's a fast-growing company going through a hypergrowth. And currently, they're operating out of a single region. They have done, going back to Joe's earlier point, they have taken steps to improve resilience posture within a single region. And now they're at a point that this hypergrowth is leading them to think about their disaster recovery, their business continuity strategy really seriously, because at this point in growth, resilience is becoming a boardroom level conversation. The cost of downtime is quite significant for them to not think about disaster recovery and business continuity. So the goal at this stage in their business lifecycle, what they're really trying to do is identify the right DR and operational continuity strategy, and also invest in testing those strategies. Whatever detection control, recovery controls, and mitigation controls they build, they want a regular testing of those controls so they work exactly how they intended to. Now, one of the first steps they took on path to that DR journey is define what the business goals look like. Now, some of you may be familiar with the two key metrics that you really need to define before you can identify the right optimized strategy is the RTO and RPO metrics. Now, for those of you who have not heard this before, just to kind of give you a very quick summary on that, recovery point objective it stands for recovery point objective. So think of this like this is the data currency your business needs to operate. Or in other words, this is the lag in the data or the data that you can afford to lose in case of any large-scale impairment with your data sources, as an example. The RTO is all about the speed of recovery. This is recovery time objective. How quickly we want to recover to back to the operations and back to the business operating and working again, typically defined in terms of minutes or hours. Now, for their purpose, this was described to be as 15 minutes of RPO and 1 hour RTO. Of course, this can vary based on industry and based on use case, based on really the criticality of that, that mission critical system that we are talking about. So based on those, the next step was to really look at what are the different strategies that they can adopt. Now, this chart that you're seeing on your screen is from our well-architected framework, which broadly classifies approaching DR across 4 different broad-level strategies. Starting with a simple backup and restore, we can argue that any critical system should have this as a default strategy. because it's not just the technology failures, it could be many different kind of reasons why you may have, say data corruption, or you may want to go back to the previously good known state. So this is kind of the, I would say, entry level, basic level strategy every critical system should think about. The next strategy is called pilot light strategy. In pilot light strategy, effectively you take a replica of your workload, of your application, and you try to create that in a different site or different region in this context. In Pilot Lite, you're focused on a couple of things. One is your data replication strategy, because you want to continuously sync data. So in case you have to recover in event of a failure, you have all the data or the current data that you need to effectively operate your business systems. And the second thing with Pilot Lite is whilst you can have all your templates and your infrastructure as a code templates ready to go, but you're not really running any compute or any capacity just yet. The idea here is that you need all the data available in the secondary region and your, the scripts that you need to bring up your and scale up your infrastructure. The third strategy here is warm standby. Now, warm standby is very similar to Pilot Lite. The distinction here is that rather than not running any compute at all, you have some base level, some baseline compute available, some warmed up resources. So the idea here is, when you compare Pilot Lite and warm standby strategy, you're effectively getting a quicker RTO because your time to recover with having all those resources or scaled down version of those resources are already there. And from there, when you fail over, you can ramp up and scale up your resources. And other end of the spectrum is active-active. By definition, active-active implies that you're using more than one region simultaneously, either for both read and write transactions or having some kind of regional sharding, or again, there's no one way of doing active-active. The idea here is that you're splitting your workload or splitting your transactions across the regions. Of course, as we go from left to right on this chart, the complexity, the cost, and operational overhead also changes. So for this particular customer, they were comfortable with choosing warm standby. It's something they thought they can meet the goals they are trying to achieve from their operational continuity needs. So next step in this journey was to start developing, start executing warm-up standby strategy. So what does it look like? So as we said earlier, in warm standby, you're taking your replica from one region, and you're making sure these resources are available, including the data, including the code and configuration that you need, readily available in your secondary region. Two key foundational capabilities you need to think about here. One is your data replication strategy. Again, it'll depend on what kind of RPA goals you are trying to achieve. In this instance, they are using Amazon Aurora. Now, Amazon Aurora has a feature called global databases. So you can actually deploy the database as a cross-region cluster where you can replicate your data from primary region to your secondary region. So you have nodes running in the secondary region. You're not actively using that region, but it's there as a passive standby region. Similarly, you need to think about how you're going to deploy your code, because what you want is your code and configuration to be also in sync between the two regions. Now, couple of call-outs here. When you're thinking about extending your code pipeline to deploy the code and configuration in your primary region, you should do this deployment one region at a time. And the reason for this is that from experience and statistically speaking, one of the biggest reasons why systems fail is when some new code and configuration shows up in the production, like a bad code or configuration, and you have to think about rolling back from there, and so it can be a very involved process. Now, if, let's say, a bad code or configuration causes any kind of impairment in the region one, guess what? If you deploy it at the same time in another region, it'll have the same problem in the region two. So you really that'll hamper your ability to recover from any event in region one in time. So you have to really avoid doing that. Another key call out here is whatever your recovery procedures are, your recovery mechanisms, your DR runbooks, you need that runbook to be available in both regions. And ideally, what you want to do is invoke those runbooks from the region where you're recovering into, your secondary region. Again, the reason is very similar. If there's any kind of cascaded impact, or let's say there's some common dependency that these runbooks are dependent on, so whatever caused the impairment in region 1 services could potentially also hamper your ability to effectively run those runbooks. So it's always a good idea to invoke these from the secondary region. So whatever failover activities are, you'll have to promote your readers to writers in the secondary region, cut over at some point, from a DNS. All those procedures and steps you should think about executing from your region where you're recovering into. So at this point, the best practices to call out that this customer in their journey have adopted is, one is that DR and operational continuity strategy should be informed by your business impact assessment. And BIA is a really good mechanism to pinpoint where the critical parts of your business are, what does that critical path look like, and what are the critical systems or the systems that's supporting that critical path. And that's how you effectively can derive some of these metrics like RTO and RPO. Because if you think about it, it's not just a technology decision. Joe was mentioning this earlier. This is a business decision. And we have to weigh this against the business case of the cost and operational overhead that comes with these architectures, and potentially with the cost of downtime, as an example. Code and configuration, we've talked about it. Think about this, the term we use within AWS is a staggered deployment. Do it one region at a time. Or even I would say if you have smaller fault isolation units, even in region 1, you do it like one fault isolation unit at a time. Let's say if you have a AZ independent workload, even deploy this, say, AZ at a time, just to build that confidence that this new release is working as effectively as you wish it for. And choose the right data replication strategy. Of course, in this example, we've shown how you can do this with Amazon Aurora. Whatever your system of record is or whatever your choice of database is, you need to think about whether you can meet your RPO goals, whether it's like a simple backup and restore strategy all the way to near real-time replication. Just think those replication strategies that meets those RPO goals. And again, ensure recovery procedure and runbooks can be invoked from the secondary region just to avoid any kind of impact that, that may impact your recovery procedures as well in your primary region. So carrying on with this journey, the next step after implementing this warm standby, this customer wanted to build more confidence in their ability to effectively failover. And one of the things we often talk about, when we are with customers talking about the DR strategies or resilience in general is you practice your ability to recover before any event happens. You build that muscle constantly and regularly, not necessarily when this event happens. So choose whatever the right frequency is to test these mechanisms. And effectively what you're really trying to test is your detection control. Can you detect a problem? Your recovery controller, based on once you get the detection or the signals, are your recovery controls, recovery procedures working as effectively, and any kind of mitigation controls you want to build as part of that process. So they adopted something we also prescribe a lot is running game days, a company-wide game days. And game days are pretty good mechanisms to test out not just the technology works, but if you think about it, these processes involve really people, process, and technology coming together, working as a well-oiled machine. So this is really trying to test is our incident response working as intended, all of the runbooks working as intended. So game days are a really good mechanism. Choose the frequency that works best for your business, based on your release cycles, et cetera. In this case, they also used AWS fault injection service. Let me spend maybe a quick 1 minute on how fault injection service can actually help you with automating or simulating some of these scenarios. So AWS fault injection service is a fully managed service that basically helps you inject failures, deliberate failures, to see how your system can withstand these failures. Effectively, another term you may have heard of we use is chaos experimentation. You're deliberately trying to introduce chaos in the system to see, again, testing your recovery controls, your detection controls. Is your observability working as intended? Are you getting these signals in time? And then are your recovery procedures acting on whatever that failure mode is? So FIS enables you to run these experiments as a managed service. It gives you these events or the actions, as we call it in the service. So things like hey, let's try and terminate some EC2 instances, or let's just try and introduce some network interruptions or EBS volume interruptions. Whatever that failure mode is that we're concerned with, you can actually effectively help simulate that. And because it's a managed service, you want to run these experiments with safety rails around, with all the in a fail-safe mode, because you don't want to interrupt your any active production services. So this service also provides you some of the guardrails around which to run these experiments. So again, what was the best practice here? Regularly test your detection and recovery control. We cannot emphasize enough that these controls you must regularly test, just so that in case that any real event happens, you are well prepared and you have a very high degree of confidence that these procedures, these runbooks will work as intended. Okay, so carrying on in this journey and this kind of incremental and step improvement they are making to the overall resilience posture, the next thing they wanted to apply in here was that they wanted to validate the failover readiness. Now, what it means is, now you may have defined all your recovery and detection control, but what if when you fail over, your target region, your secondary region has some mismatches in the base level features that you need or base level configuration that you need for effective failover? For example, do you have the same limits that you have in your primary region? Have you checked all the service level limits? Because if you apply for limit increases during an event, guess what? You're compromising your recovery time objective. Things like provision capacity. If you have certain services support provision capacity, do you have any mismatch between those, between the regions? So making all those checks, those readiness checks, is again super critical beyond the recovery and detection controls we've been talking about. So in order to do that, they basically adopted a Route 53 application recovery controller. If you're not familiar with this, I'll give you a very quick intro to this. So application recovery controller, or ARC, is part of the Route 53 service. And it helps you at a macro level. There are three key benefits of adopting application recovery controller. One is the readiness checks, as we've been talking about. So it will constantly, at a 1-minute interval, check for audit your whatever parameters and configuration you have provided on the secondary region. Things like examples like I was giving earlier, what's the limits or any kind of mismatch in provision capacity, et cetera. And there's a whole bunch of other checks that it comes out of the box. The second thing is the routing control itself. Now, when you fail over, especially in these kind of architectures, this scenario that we are talking about with warm standby, which is really an active-passive architecture, whilst we recommend you should automate all the steps, like all your runbooks and everything should be automated, but the decision to actually pull this proverbial lever to shift the traffic from one region to another should be done manual. And really the reason for that is it's a very involved decision. You need to be absolutely sure when you make that final decision to shift the traffic, that you're absolutely ready to take that. So readiness checks kind of play into that, because you want to be absolutely sure that when you open the traffic gates to the second region, you have all the capacity you need, you have all the data you need, and all the readiness checks are showing you green signal before you invoke any kind of switchover at DNS level. And the third thing is, because it's such an involved an important process, you want to have some safety rules. You need to have some guardrails around, invoking this lever unintentionally. So you can actually put some checks in place. So that's another kind of the feature of ARC, that it gives you safety rules that only when these rules are met, that after pulling the lever, this will be actually actioned. The routing control will be actually actioned based on those rules. So at this point, the best practices to call out is build failover checks as part of your recovery strategy beyond your recovery mitigation and detection control. You want to be absolutely sure you're ready to take the traffic on your secondary region. Use ARC where you can, because it'll simplify and automate a lot of things which otherwise you will have to self-build yourself. And by the way, this is not just for the failover. Because when you fail back, when you shift the traffic back from the secondary back to your primary region, you need to go through the similar level of thinking that you do at a failover. So ARC can actually help you in both scenarios. And again, I would like to emphasize automate as much as possible because that more automation will get you faster to your RTO goals. But the final decision in these architectures specifically should be manual. Right, so let's carry on. Again, we are making incremental improvements. This customer is on that path to adopt continuous improvement on their resilience journey. The next thing they observed was in their observability stack. So the situation was that in order to trigger the failover mechanisms, or failback mechanism for that matter, you really need to rely on the signals. And those signals are provided by your observability stack. So observability, if you think about it, that's where your detection control plays in, is a very foundational capability you need in place. And you need to think about the same, if not more, level of resilience of the observability stack itself as rest of the workload. Because if you're not getting those signals and you're not getting those signals in time, it will hamper, again, your ability to recover in time. So in this case, the realization was that, hey, you're running the observability stack in region 1, and it can help you detect those signals. But what if your observability control, your detection control itself is impaired? This is very similar to the first concept we were talking about in the recovery controls. Now, this is the situation with your detection controls. If, let's say, there's some common dependency or some common cause of underlying impairment, your whatever instrumentation you have done with your observability can also be impaired. So in this case, what you really want to do is what they did here was extend the observability stack across the region. Now, even though in this situation, they're not actively using the secondary region, but you need observability. You need to observe both regions, at least at a shallow level health check, even if it's some kind of heartbeat metric that you can have. So you can observe a region from outside, or what's going on in the region from outside of the region, and correlate both what you can see within the region, but also what you actually observe from outside of the region. That's really important as part of thinking about the observability, because in case there's something impaired within your observability, by having this outside perspective, outside observability for your region, you can make a more deterministic decision on whether or not there's something wrong, and then make your failover decision based on that, based on those signals. So again, the best practice here we want to call out is observe region's health, not just from within, but also from outside of that region to make that deterministic choice or decision for failover. Okay, so after having all these incremental improvements, this is what this architecture currently looks like. Its current view, or what we like to say, it's evolving view, because you're never done with resilience. Resilience is a continuous improvement journey. And one thing I want to call out here is by taking all these incremental steps, there were also certain trade-offs, to make as part of this. Of course, it made absolute sense in the context of their business and the criticality of the systems they were running. But the trade-off here was, operational overhead. Think about all the cross-region observability, looking at your data replication, looking at how your deployment is going on. So there's an additional, operational overhead, and which comes with some additional complexity to think about. You have more steps to think about as you think about failing over and failing back in these architectures. And of course, this also leads to some additional cost to think about. So again, going back to the previous point I mentioned in the beginning, that these architecture or going down this path is not purely a technology decision. It has to be led by business. It has to be led by a business case. So with that said, I'll let Joe run through the next scenario.
Excellent. Thanks, Niraj. So our next customer scenario is going to be an online authentication provider, providing authentication as a service. This is also a fast-growing company, and as this fast-growing company was evolving, they started to run into two primary problems. The first problem was as they were taking on larger and larger customers, which is a good problem to have, they noticed that these larger and larger customers wanted to have contractually set SLAs within their contracts. And they didn't have any that were set, and they knew that they needed to increase their uptime SLA that were going to be set within these contracts. Also, as they had more customers worldwide and more users logging in from more locations, they noticed a few metrics from support cases and online threads, as well as their own internal metrics, that users in different geographies were getting vastly different performance from the same exact workload. So they sat down and they understood these requirements. They wanted to improve the uptime SLA to 4 nines of availability, and they wanted to increase the overall application performance by reducing the latency by 30% at a global level. And they wanted to do this specifically for the most important API, which was their authentication API. You can see a brief architecture diagram here. This is currently a single region application. Users come in, they first hit an API gateway endpoint, and then depending on the request, the users will be directed to either a Lambda function or an application load balancer that has both ECS instances, ECS containers, as well as EC2 instances. Then there's a persistent storage layer at the bottom there that consists of both DynamoDB as well as S3. Now, as this customer began on this journey, they first wanted to start to build up this environment in their lower environments, and they quickly came across their first problem. They realized that about 20% of the workload was either not defined within their infrastructure as code templates, or there was some significant drift between what was in the infrastructure as code templates and what was actively running in production. So they needed to really take a step back and do a full audit of the workload from start to finish and ensure that what was in the infrastructure as code templates matched what was running in production. Because they knew that doing manual releases and manual changes, especially as they go across multiple regions, was going to be troublesome. There is going to be error prone, and it was also going to take more time. So to essentially ensure that they have consistent deployments across all of the regions they're deploying into, they adopted AWS CloudFormation. And within CloudFormation, they broke down the application into separate stacks. These stacks were, for example, one for the front end, one for the back end, one for shared services, another one for the data tier. And within these stacks, within these templates, they then created a CloudFormation stack set. And within this CloudFormation stack set, what that allowed them to do is deploy that same stack to multiple regions. However, they knew, again, that they didn't want to deploy to all the regions at the same time. They wanted to allow for sufficient bake time or sufficient time after the deployment to ensure that the deployment was healthy before extending that deployment to other regions. So to accomplish that, they used a mixture of parameters within CloudFormation and also wait conditions within CloudFormation to ensure that we're only deploying to one region at a time, and then we're waiting a sufficient amount of time before deploying to the next region. The next problem they needed to overcome was understanding how they can have a globally distributed, intelligent, and reliable routing layer. So they wanted to ensure that users, when they came into the application, were automatically routed to the location that was most relevant to them, which in this case had the lowest latency for them. So to accomplish this, they utilized Route 53 latency-based record sets. And what these latency-based record sets essentially do is a user comes in, they make the request to the Route 53 record. Route 53 determines the application that would have the lowest latency for this particular request, and it returns the IP for that application that would have the lowest latency. So the user is then directed to the relevant region with the lowest latency to them. They also wanted an easy mechanism to be able to shift traffic away from a region to evacuate it, for example, for maintenances, but also if there's some unforeseen problem or unforeseen issues within one of the regional deployments. So for that, they also utilized Route 53 Application Recovery Controller. And what this does is it essentially attaches health checks to that latency-based record set. And this utilizes the Route 53 highly available data plane to flip the switch on those health records to dictate what regions can be routed to, essentially which regions will be returned to from the Route 53 records. Being an online authentication provider, security was always top of mind for them. So they also wanted to have additional protection for things like SQL injection and cross-site scripting attacks and other layer 7 attacks. So for that, they deployed an AWS Web Application Firewall in front of the API Gateway endpoint. So let's take a quick second to catch our breath and look at some of the best practices from these first slides for this scenario. First, as you go to a multi-region architecture, deployment best practices, CI/CD best practices are going to become ever more important. Utilizing infrastructure as code will help to ensure that you have the same consistent deployments across multiple different regions. And then utilizing things like regional parameters and wait times and wait states as another best practice is to only deploy to one region at a time, allowing for sufficient time after that deployment is complete to maybe uncover any unforeseen problems. Also, this customer spent quite a bit of time figuring out what was the best solution to create that reliable and intelligent routing layer. Their particular use case, they utilized Route 53 latency-based records as well as Route 53 our application recovery controller to both route users as well as to direct them for maintenance and for possible impairments. Now, as you can probably imagine, this is a very read-heavy workload. Right? Users make a lot more requests to authenticate in the authentication APIs than they do to make changes to users' permissions. However, when a user's permissions need to be changed, for example, revoking those permissions, customers want that to happen as quickly and as reliably as possible. So let's take a look at how they accomplish this. First, they looked at both synchronous replication and asynchronous replication. However, with a two-region deployment here, they chose against synchronous replication for two primary reasons. The first reason was because a single write going into the application would need to be fully consistent and acknowledged from both regional deployments. This meant that a problem with one of the workload deployments would take down the entire workload. Thus, because the dependency was spread across regions, and this could reduce their availability. The second reason was because, again, any writes going into one region would then need to be acknowledged from the secondary region. This is going to increase the latency and increase the time for these writes to happen. So those two requirements that they had at the beginning were to improve availability and increase performance, and that went against those. So for those reasons, they chose asynchronous replication, and they did that with DynamoDB global tables. So DynamoDB global tables offer them a multi-region, multi-writer database solution with typical replication lags between the regional deployments of 1 second or less. There's also built-in features such as conflict resolution with DynamoDB global tables, such as if the same request comes into both regions, then the last writer is going to win in that case. Now, for the use case where a user comes in and they need to change a user's permission, for example, let's say we need to revoke a user's permission because they no longer need that access. So for that, they utilized a concept called hedging as well as having idempotent transactions. Let's take a look at what I mean by that. First, let's use a scenario here where a user comes in and they have a request. This request is going to be to revoke user A's permissions. That request is then sent to an intelligent SDK. The intelligence within this SDK is primarily that the SDK is aware of all the healthy regional deployments of the application. Now, once it hits that SDK, the SDK realizes that this needs to be sent everywhere because it's a highly resilient or highly important request. So it sends that request to both regional endpoints at the exact same time. Now, due to things such as the speed of light and latency over long distances, it's not going to reach both of those regional endpoints at the same time. But it is going to reach both of those faster than if it was only going to go to one regional endpoint and then replicate it to the other. Thus, we've essentially reduced our P99 latency in this case. We've also protected against any potential network transmission issues. So maybe a latent network problem where a request doesn't make it to one of the regional endpoints. That request is still going to make it to the other regional endpoint and then asynchronously get replicated via DynamoDB to the other region. One very important note here is that all of these transactions, all of these requests were idempotent. And what I mean by that is that if the same request is made multiple times, the end result is not going to change. How they did this in this scenario was the user's permission set that is changing. Within the request, the entire user set is being sent within that request, such that the new user's permission set is not determined based on the previous user set. Now, when it comes to multi-region architectures in data replication, many times the biggest thing to overcome is just the speed of light and how fast we can transfer data. The speed of light is very, very fast, right? However, when we put it into fiber, which most data transferred over long distances is done, and we add on top of that routing protocols and transmission, retransmission, transferring data over long distances is much slower than the speed of light. But really what this boils down to is the longer the distance the data needs to travel, the more latency that is going to be put into the workload. And to help out with this and to understand what options you have, we have a core theorem. That core theorem is called the CAP theorem. The CAP theorem was created specifically for distributed systems, and it states for a distributed system, which a multi-region architecture is, you have to choose between 3 options: availability, consistency, and partition tolerance. Now, because we have a multi-region application spread across multiple locations, we usually need to always have partition tolerance here. This leaves us with really 2 options. One is consistency and partition tolerance. This is useful if you have an application that has really strong consistency requirements. However, the trade-off here is that there could be decreased performance and decreased availability because now a write needs to be fully persistent across both locations. If you do have an application that has strong consistency requirements, in a scenario such as this, you might want to think about adding a 3rd region and then using like a quorum-based model. So 2 out of 3 writes are required to be fully acknowledged before that write is fully consistent. The second option, though, and the one that I would say probably the majority of customers utilize, is availability and partition tolerance. So with this, customers gain the advantage of increased availability for the workload. However, the trade-off is that the workload needs to be okay with eventual consistency. And if there's a problem with one of the regional workloads, then any in-flight transactions could potentially be lost. However, the increased availability is a big winning point for that. Now, if you do choose the second option there, availability and partition tolerance, some core things you're going to want to make sure you're monitoring are simply like data replication. So utilizing, in this scenario, both DynamoDB global tables and S3 cross-region replication. Make sure you're monitoring the replication lag between the 2 locations and have an appropriate alert set up such that if the replication lag increases by so much, then we're going to alert our on-call engineers and take appropriate action. It was also very important for those customers, since they're trying to increase availability across the world, to understand availability metrics and measure that appropriately. So they did a few things here. They took this standpoint from 3 different angles. The first angle was simply looking at the server logs, and from the server logs, what are they seeing for error rates? What are they seeing for processing time for a request? The second was they ran synthetic checks. Synthetic checks not from the region that was being monitored, but from a different region, either region 2 or even a 3rd region. And what these synthetic checks were doing, we're going through common user workflows and monitoring the active duration for that workflow, and then alerting if the duration exceeded what was expected. The third viewpoint then was from the user's endpoint. So they utilized CloudWatch Real User Monitoring to get a really good understanding of duration and error rates from the user's endpoint, and then they fed that into to the monitoring tools. We call this differential observability, where they are taking a viewpoint, 3 different viewpoints here, to try to gain a more holistic and more true viewpoint, a more true data point of how healthy the application is. This allows them to not only understand how healthy the application is holistically, but also allows them to understand and dig into problems that might not have been seen by only taking a single viewpoint of the workload. So again, let's take a break to look at some of the best practices from these. The first is that understand the consistency characteristics of your workload, and then the replication options that are available to meet those consistency requirements. Many customers use asynchronous replication, for simply improving availability of the workload. But we did talk about using a quorum-based model if your workload does have strong consistency requirements. If you do have a multi-region, multi-writer workload going on, then you're going to need to make sure you have appropriate checks in place to ensure for consistency. So making sure your requests are idempotent, making sure you have some kind of conflict resolution in there, and then detecting any inconsistencies that might happen because you're writing to multiple locations at the same time. And then we talked at the end there about differential observability. One viewpoint of your application is good, but the more viewpoints from different perspectives by utilizing differential observability will give you a more holistic, true health of your application. All right. The next thing that this customer wanted to ensure was that they needed to ensure that each region could work and function 100% independent of the other regions. They didn't want a problem in region 1 to affect region 2. So this is what we call regional independence. And they did that by enforcing very strict fault isolation boundaries at the regional level. So what this essentially boils down to is there's no cross-region calls, there's no cross-region dependencies for the application in region 1 and region 2. And then they tested to find these unknowns. So during a planned event, they actually shifted all traffic away from region 1, so all traffic was going to region 2. And when they did that, they noticed that many resources within region 1 were still being actively processing data. This allowed them to uncover those unknowns. And it turned out to be a legacy system that was making some backend calls that were just not expected. But testing helped them to uncover that and then put into place these more strict fault isolation boundaries, again, at the regional level. Now, as this customer went on this multi-region journey, they did a pretty good job of estimating cost as it pertained to their increased IT spend, their increased infrastructure cost. However, they admitted they did a pretty poor job of estimating the operational cost for the workload. So they needed to take a step back and really understand from an operational standpoint where the operations costs were going and what was the expectations going forward. So they needed to relook at policies and procedures as it relates to not now a single region application, but a multi-region application. For example, runbooks needed to be updated for simple things, such as when an alert comes in, the first thing we need to do is determine what region it's coming from, which regional deployment is coming from. They also needed to create completely new runbooks for things like evacuating a region or shifting traffic if they needed to for maintenance. These runbooks also needed to take into account different running states. So, for example, if the application was fully healthy and they needed to evacuate a region, then they're going to probably take different steps than if the workload was partially unhealthy, where not everything was fully available. In the partially available standpoint, they wanted to ensure that all actions were going from the healthy region. The last thing here was many service quotas are set at the regional level. So as a workload grows, you're likely going to make service limit increases. And just know that these service limit increases, the vast majority of them are not at the account level. So make sure that you're tracking those service limit quotas. And then when you go to multi-region architecture, as you increase the limit in one region, make sure you're also increasing the limit in the other region. And you can use the AWS service quotas service for this. And this can also help you to check and understand the different service quotas as defined at the regional level. And you can also make service limit increases from that service as well. All right, so more best practices that we uncovered here. The first is understanding your dependencies and architecting for regional independence is going to improve the overall resilience of your application. Allowing for regional independence, so each regional workload can function 100% independent of the other regional workloads. Also, as you're planning and budgeting for your expansion here, don't forget about the increased operational overhead. So increased operations and what that's going to mean specific for your application. Service quotas are mainly set at the regional level. So if you're increasing the service quota in one region, make sure you have runbooks and checks and those things in place to ensure you're doing that for all relevant locations. And then as you're updating your runbooks, make sure you're also taking into account healthy state, unhealthy state, and knowing what different procedures to run with different states for your multi-region workload. All right, if you remember at the beginning of this customer scenario, they needed to really kind of shift that mindset to have everything done within infrastructure as code, which is great, and the company and the engineers were doing that. However, it's important to also put in additional checks. Put these additional checks in place to ensure, especially in this scenario, that region A is the same, or region 1 is the same as region 2. because they didn't want for a user to go into different regions and have a different user experience. That was very important. So for that, and to help with the detection, they again utilized Route 53 ARC to have some readiness checks. And these readiness checks are going to continually pull the resources in both of the regional locations and looking for things like service limits and quotas and throttling and any other version differences that may happen. And then it'll alert when those inconsistencies are found so that somebody can go and remediate them. Next, so this customer was successful in deploying their application across multiple regions, but one of their core requirements, again, was to increase their overall performance for their end users. And they knew that as they increased performance at a global scale, they were going to be able to open up new markets and new companies for their product. So as they were looking at which region they wanted to go into next, they needed to create a framework for that. And the beginning of the framework is right here. First, they looked at where their users were coming from, specifically where they were coming from that had the highest amount of latency, and then doing that analysis by the volume with the highest latency. Next, as they kind of narrowed down the region they wanted to go into, today we have 32 regions around the world, and they narrowed it down based on where they were seeing the highest amount of latency. Next, they looked at what the cost was. So different regions can have different pricing for different AWS services. And this is because it costs us different amounts to provide services because of things like taxes and labor and power and materials. These can all be vastly different based on different geographies in the world. So for those reasons, it costs different in different regions. The best place to start here is by looking at the AWS public pricing pages as well as the AWS pricing calculator. And those will help you to determine the cost differences between the regions. The third one here was then the service availability. So not every AWS service is available in every AWS region. We do have initiatives to try to make sure that everything is available everywhere. However, we admittedly have a pretty long ways to go there. So if a service is not available that you need in a region that you need for your workload, go ahead and let your AWS account team know. 90 to 95% of a roadmap is directly influenced based on that feedback from you. So what this customer did was they did a full inventory list of their workload for all of the AWS services and features that were being used, and then matched that against the AWS public pages for the regional availability of each service. All right, some final best practices here learned from this customer. The first is that, especially to have some kind of tooling in place to detect inconsistencies between different regional workloads, especially in an active setup like this. You don't want users to have a different user experience depending on the location that they go to. Also, as you're selecting the region to go into, there's a lot to consider, and make sure you're figuring out what works best for your workload, for your business, and for your users. Looking at things like the user's location, latency to them, costs, and service availability are some very common ones. So here's our current evolving architecture. It's always evolving here. We didn't talk about everything due to the limited amount of time here. We only hit on the top 10 items. But you notice that we missed a few things, such as these ECS containers and replication, how the Lambda functions are going to be deployed, the ECS or the EC2 instances as well. So it's important to kind of take your time, first understand your requirements, and then take it step by step and piece by piece to be able to evolve your architecture into a multi-region one. Now I'm going to hand it back over to Niraj to wrap us up.
Great. Thank you, Joe. All right, so based on these two stories, these two scenarios, let's just have some concluding thoughts or the key takeaways we want you to take away from this presentation. So the first point is that AWS regions, and Joe covered this in the beginning, they're built with they're highly resilient, and with all the infrastructure level redundancy through availability zones, et cetera, that you get. So most applications do not require necessarily to be multi-region. So have that reasoning, why go multi-region, driven by your business needs, driven by what you're trying to, driven by your business case, to be very specific. And some of the nuances that you saw specifically in the scenario that Joe walked through is the data and dependencies. It can be complex. So we have to be very thoughtful before we embark on the multi-region journey, what kind of dependencies we are taking, what kind of data access patterns and data consistency needs we have, because depending on that, it will steer you in a specific direction, especially in the case of active-active, which can be quite complex. You have to think about idempotency and all those other things that comes with those architectures. Observability, again, cannot emphasize enough, this is the foundational rock for you to build either single region resilient applications, or in this case, multi-region resilient applications. So observability and how you're deploying the code, how you're testing again, going back to the recovery, detection, and mitigation controls is fairly important for you to think through ahead of time before you embark on this journey. And of course, there are additional costs you need to also think about when you're deploying these. And again, this is, we're really scratching the surface in this presentation. There's no single way of doing multi-region. Even, let's say, active-active example, there are several different ways how you can implement active-active or active-passive multi-region architecture. So driven by your business cases, and of course, we are here to help. Work with your account teams, work with your AWS representatives to help you, steering in that kind of direction. So a couple of resources I want to real quick call out. As I said earlier, this is not super deep, but if you want to understand more about this topic, we did publish a white paper on multi-region fundamentals. One of our colleagues, wrote this a few months ago. It goes into a lot more depth that we have covered, but based on the similar best practices that we've been discussing in this session. Another white paper we recently published is the Resilience Lifecycle Framework. And if you just even Google search, you can take a pictures if you want of the code there. Resilience Lifecycle Framework, it really shares the strategies, the mechanisms that you should be thinking through these different stages. This is like, really based on the SDLC model. So as an example, setting objectives, understanding your requirements, or when you are at design and implement stage, what kind of resilience thinking you need to bring, or, so it's not just about multi-region. This is kind of a very broad resilience best practices white paper aligned to the lifecycle notion that we have in this framework. And of course, besides this thought leadership, we are also, based on your feedback, the feedback we get from our customers, we are also investing in, different resilience offerings. A couple of them we did touch on in this presentation, fault injection service, which can help you, manage your chaos experimentation. We also talked about Route 53 application recovery controller for having this kind of routing controls and readiness checks. But there are other services, again, we have not touched on that you may want to take a look at. One is like application AWS Resilience Hub, AWS Backups, specifically if you're thinking about entry level, this kind of base level strategy around backup and restore we talked about. Again, Elastic Disaster Recovery is another service which you can think about, when you're thinking about those multi-region DR strategies. Besides that, we also publish a bunch of AWS solutions that we have a landing page if you just search AWS solutions where you can find some of these multi-region and many other resilience-related solutions that we have published over a period of time. So I think with that said, I want to thank you all for coming in. And again, this is late in the day, so we really appreciate your time. We would request you to leave the feedback. It's going to really help us to continuously improve these sessions. So thank you very much, and enjoy the reInvent.